Hello everyone, today we're looking at Unit 6, Lesson 1, Similar Triangles. So as we start exploring this unit on trigonometry, let's first break down what is trigonometry. So the tri part of trigonometry refers to triangles, and the last part with the kind of nometry at the end refers to the geometry of triangles. So when you put it together, we're talking about triangle geometry basically. So we're going to be exploring different types of triangles in this unit. Primarily, we're going to look at right triangles, so a triangle that has 90-degree angles. And then we will also look at what we call oblique triangles. So those are triangles that do not have a right angle basically. So we're going to start today talking about similar triangles. So similar triangles have the same shape, but not the same size. So let's just highlight some of this information. So same shape, not the same size. So basically it's taking a triangle and either enlarging it or reducing it. Okay, but it's enlarging or reducing at a scale, so it's still proportional to where it first started. In a similar triangle, corresponding angles are equal, so we'll talk about what this looks like. And corresponding sides are proportional, which means that the ratio of the sides are equal to each other. So if we take a look at this example here, we have two triangles. We have triangle ABC and we have triangle DEF. So if we were to say that triangle ABC is similar to DEF, well, there's a certain mathematical sentence we have for that. We would say triangle ABC is similar. So we make this little swirly line called a tilde. So this says triangle ABC is similar to triangle DEF. So what we're saying, and it's very intentional the way we list the letters in this, if we're saying triangle ABC, we put the ABC in that particular order because it relates to triangle DEF in that order. So meaning A relates to D, B relates to E, and C relates to F. So when we're talking about our angles, for example, notice that my angles are the capital letters A, B, C, and then in this smaller triangle, our angles are D, E, F. So if they're similar, that means the angle A is equal to angle D. Okay, we could say that angle B is equal to angle E, and angle C is equal to angle F. And just in case we're not used to seeing it, this little symbol here means angle when we see that. Okay, so what we're saying, if we wanted to represent this within the triangle, we could show this little kind of arch saying that angle A and angle D are similar. If I wanted to show the angle B and E, I'm going to do two arches just to make sure that I can know which ones I'm referencing. So angle B and E would be equal. And then for C and F, we'd say we could do three arches to show, okay, these two angles are equal to each other. Now, when we're talking about our side lengths, remember that if we wanted to label our side lengths with a letter, it's going to be the lowercase version, and we saw this back in analytic geometry. It's going to be the lowercase version of the angle that's opposite that side. So what I mean is like angle A, the side opposite it would be right here. So that would be a lowercase a. Side B would be opposite angle B. And side C would be opposite angle C. And we can do the same in this triangle. So we'd have D, E, and F because they're opposite their corresponding angle. So it says that the corresponding sides are proportional. So what I mean by that is if we look at the sides that are proportional to each other, they're going to be in the same spot basically in that triangle. So you can see that side A in the big triangle and side D are located on the same kind of plane or the same side of the triangle. When we're setting up a proportion, this is basically going to be the ratio of corresponding sides. What I mean by that is if we've established that this is similar, then we're showing that side A and side D are proportional to each other. So notice that we took side A from the big triangle and we took side D from the small triangle. And we could write this proportion statement for all the corresponding sides, recognizing that if we have A over D, that should equal the same as the ratio of the other corresponding sides. So we also have, that should be equal to B over E, which should be equal to C over F. So the ratios of those three pairs should all equal each other. We could also write this in terms of its vertices. So sometimes some of us prefer to label a side by its vertices. So I'm just going to write or. So if we were looking at side A, we could also say, okay, side A could be represented by CB, right? It could be between those two. So we could say CB over, and then if we look at D, that could be represented by F over E. So I'm just going to do that for all of them. So then B we could represent as AC over DF, and then we could represent C as capital AB, and then F would be DE. Okay, so that's just labeling using those vertices, but you're going to see us using more of the lowercase letters in this unit. So the first question we're looking at here is, are triangle MNO and triangle XYZ similar to each other? So remember, what this is saying is that angle M would be equal to angle X, angle N would be equal to angle Y, and angle O would be equal to angle Z, which also means that those opposite sides are corresponding to each other. They should be proportional. So let's check our side ratios to see if they all equal each other. Okay, so we know that M corresponds with X. So if we wanted to label, we know that this is M, this is N, and this is O. And then in my other triangle, this would be X, this would be Y, and this would be Z, right? Because it's always opposite the angle. So we would say that M over X, those are corresponding sides. So that's going to be 3 over 6, which reduces to 1/2. So we know the ratio of those two sides is 1/2. Let's check some of the other corresponding sides. So another corresponding side pair would be N over Y, which would equal 4 over 8, which is again 1/2. And then our last pair we have is O over Z, which would be 7 over 12. Now 7 over 12 doesn't reduce to 1/2. So the ratio is not the same as the other two. So let's just say this ratio is not the same as the other two. Therefore, triangle MNO is not similar to triangle XYZ. Right? All three of those ratios need to equal the same fraction or decimal when you simplify them in order for those two triangles to be similar to each other. So moving right along here, we're going to continue working with similar triangles. They're asking you to find X and Y. So when you're given triangles like this, where they're not oriented the same way, I just want us to make a note here that we should redraw one of the triangles to be oriented, which means like basically turned so that all the equal angles and the similar sides are all the same direction. Then it's easier to kind of compare, okay, this is my corresponding sides, these are my corresponding equal angles. So let's just make a note here that we're gonna draw one of the triangles to be oriented, which just means like turned or seen in a different kind of direction, the same as the other triangle. So this next example is asking us to find X and Y. We are going to assume that triangle ABCD BC is similar to triangle FED. And remember, I'm very intentional with the way I've written that similar statement because we want to make sure that we have the letters in the same order in which they're related to. So we're going to redraw triangle ABC to look like triangle DEF. So I want to turn triangle ABC so that it's laying the same as triangle DEF. So if I was going to do that, okay, triangle DEF has its right angle here. Okay, well the right angle on ABC is angle B. So I'm going to redraw it like that. And then if I think about what's similar here, notice that we have this tick mark here and here, which means those two sides are corresponding to each other. So that means that I want triangle ABC to lie the same way. So I'm going to put C up here so that, again, I can have the corresponding sides be the same. And also these two sides are the same, right? So we want it to lie that same way. So then this must be A here. So we can fill in some of that information we're trying to find. For C, we're trying to find angle C, which they've said is X, and we're trying to find angle A, which they've said is Y. Okay, so knowing that these are similar triangles, we can hopefully see that angle F and angle A are going to be the same because they're similar triangles. So we can say angle A is going to equal angle F. Well, we know that angle F equals 30 degrees, so angle A must equal 30 degrees. Okay, we also can see our other angle we don't know is angle C. Well, angle C has to equal angle D. We don't know angle D, but we can certainly find angle C or D by just taking 180 and subtracting the sum of the other angles, the sum of the interior angles. So minus 90 plus the 30 we already have. So we could say angle C is equal to 60 degrees. Okay. So in this case, then X would be 60 degrees and Y would be 30 degrees. Okay, because we know in similar triangles that the angles are equal to each other. So the next one says find X. Again, we're assuming that the triangles are similar to each other. So I'm going to redraw this small triangle so that it's oriented the same way as the bigger triangle next to it. So I'm basically going to take CED, this triangle, and flip it so that it's facing the same way as the other triangle. So we're going to have it like this. And we're going to label the letters accordingly. So this was D, this is going to be C, and this is going to be E. And we know that we have 7 meters here, and we have 3 meters down here. So we can now see which sides correspond with each other in triangle DEC and ABC. So let's set up our ratio of corresponding sides to find X. So we're going to set up the ratio of corresponding sides. Okay. So I'm going to start with putting my big triangle on top and then my small triangle on the bottom. You're going to see through multiple examples that it doesn't matter too much which one you put on top, but it's always a good idea to put the unknown on top. So the unknown in this case is X, which comes from our big triangle. So that's why I'm going to stick the big triangle on top. So my big triangle, my corresponding sides are going to be where it's X, and that's going to correspond to side length C in my smaller triangle. I could say C equals, right? So X over C. And that's going to be equal to, this is side A, and this is side E. So we can see that those are corresponding sides. So that's going to be equal to A over E. So this is what we call these two ratios being equal to each other. This is our proportion statement. So now we can just plug in the values we have. Okay, so x, we don't know still, it's just x, over c. Okay, so side length c is here, right? So that's going to be 7. That's going to equal a, which is 12, over e, which is 3. Okay, so to solve this, we are going to now cross multiply. Go from here to here. We're going to multiply the numerator and denominator together and multiply the numerator and denominator together. So we'll have 3 times x on one side and we'll have 7 times 12 on the other side of our equal sign. So that equals 84. You can say x equals 28, and we're going to put meters because you should always include the units if they're given to you. Okay, one more similar triangle question to try. So we have a kind of a triangle within a triangle here, right? We have a bigger triangle of R, S, and V. Let's see if I can make that line a little straighter. And then we also have this tiny triangle inside of that. We have triangle U, T, and V. Okay, because we have a triangle within a triangle, we can also assume similarity here because we know the 90-degree angle will be the same. And we also know this angle is going to be the same for both the big and the small triangle. So that would mean the third angle would have to be the same. So I'm going to redraw the big triangle just so we can see them kind of broken apart. So redraw big triangle. And again, I want them to be oriented the same way, which they already were. There was just one inside the other. So we're going to say that this is R, S, V. And we're going to label what we know. Okay, we know this is a right angle. We know that this side over here is 7 meters. And we know this side across the bottom, which would be the full length up here, is going to be represented by 5 plus x. Okay, because the side length up here is 5 meters from S to T. But if we're going the full length, right, we have to go all the way to V, then we have 5 plus we have that x. So if we're going to set up our proportion statement or set up the ratio of our corresponding sides, this time I'm going to put the small one on top just so you can see that it'll work both ways. There's a couple unknowns in this one though. So we're going to write the small over the big triangle this time. And I'm going to represent this with vertices this time, just so you can see for both of them. So if I'm saying my small triangle, well, I have my small triangle, I have TV, right? So TV, which is this side here, is similar to SV. Okay, so we're going to say TV over SV is going to equal, and then if we look at some other corresponding sides, we have UT. Right, so UT is going to be corresponding with RS. And again, this ratio equaling each other, this is our proportion statement. This is our proportion statement when we have two ratios equal to each other. So TV is represented as x. SV is 5 plus x. And we're going to set that equal to UT was 4.5 and RS was 7. So once again, I'm going to cross multiply to solve. I'm just going to make that note so we remember. So from here, the algebra we're going to use is going to be cross multiply. So we're going to have 7 times x on one side, and we're going to have 4.5, and we're going to put what you're multiplying it by in brackets, right? Because we're multiplying that whole thing by 5 plus x. So we have to distribute that 4.5 into our bracket. So 4.5 times 5 and 4.5 times x. So 4.5 times 5 is 22.5, and 4.5 times x is 4.5x. Okay, I'm going to work to isolate x, so I'm going to move the 4.5 over to the other side. So we have 7x minus 4.5x, which equals 22.5. So that's 2.5x equals 22.5. And then I'll divide both sides by 2.5, and we should get that x is equal to 9 meters. Okay, that's all for your notes for today.